Hey guys, it's Vince. Today in this video, we're going to be taking yet another look at a YouTube content creator's misinformation-based video around servo or stepper motors. It's a debate that's gone on for years. I myself personally have covered it on my channel probably 100 times over the last decade, and I can tell you truthfully, what we need is more evidence-based material around this topic, and therefore I wanted to do this video and present you with factual evidence you can view and see yourself direct from motor manufacturers and also end users. So let's jump right in.
Today's video we're going to be taking a look at the CNC router and an upgrade that I had performed on it.
Okay guys, just to be clear, a motor upgrade typically is revolving around the torque the motor produces. When we discuss changing a stepper to a servo, that should not technically be an upgrade, because if a stepper system is set up correctly based in the parameters of the transmission selected by the end user, then the performance it yields should be on par with what applications you're running. So think about what I just said. And I'm going to prove that as we go through this.
Probably about a year ago, maybe a little longer. To be honest, I lost track of when I did it. But what it entails is replacing the original stepper drive system that I had on here. Stepper drives are wonderful devices, and if you stay within their functional parameters, they can be incredibly reliable and incredibly accurate. However, if you wander outside of their performance envelope, all of a sudden you start losing steps.
Okay guys, what we typically have is just like this end user is doing. He's trying to basically take a servo and make it to where the stepper has problems. So he's trying to say, I went with a servo because a stepper has problems because it's an open loop system in that it can miss steps. Well, let me clue you in on something. A servo can also give you a read error if you run it past its operational envelope. So the key point here is to understand what these motors are telling you when you exceed their operational envelope, regardless of what motor type it is. A stepper will miss steps because it's an open loop system. Therefore, it doesn't have an encoder giving you positional location. When a servo misses steps, or once again is run outside of its operational envelope, it'll give you a read error or an encoder error based upon your software if it can detect it, and therefore not allow the servo to operate. The point is, it's irrelevant what motor you use. The key thing to keep in mind is every system will have its operational envelope. None of us just run motors not connected to a transmission. So if they are not properly matched to a transmission, you will get issues with either missteps if it's a stepper-based system, or get encoder issues if it's a servo-based system. And the other point is that EMI is still present on both types of systems, and both types of systems can be vulnerable to EMI penetration on signals that are to manipulate control. The big misconception is that if you're using an encoder on a servo, that miraculously it's impervious to noise. It's not the case, gentlemen. So again, what we see here is an end user trying to cope with the fact that he's just spent a lot of money on servos because for whatever reason he was told they're better, and he's trying to justify it by making a stepper sound as if it's not as accurate, it's not as good, it's not going to provide you the machining capability of a servo. This is just not accurate. We're going to go into detail.
And then positioning goes away, and now you've got a reliability issue. If you're familiar with 3D printing at all, a lot of those layer shift problems are lost steps. Something is blocking the drive mechanism from achieving its position.
Okay guys, here we go again with some more misinformation. Many of you own 3D printers as myself, and I can attest that typically you're never ever seeing an obstruction on your 3D printer's transmission, yet what you are seeing is end users, myself included, will tweak speeds until we get to that envelope operation where we do generate missteps because we're trying to get a job completed in a faster format. And why we're generating missteps is because we're exceeding the operational envelope of the stepper motor tied with its said transmission, as I just discussed. Regardless of the robot type, if you exceed the operational envelope of your stepper motor and its transmission combination, you will generate missteps.
so it just skips steps. And then from that point on, everything is shifted by those lost steps. In the industrial CNC world, we rarely ever see stepper motors used for motion control. It's almost always servo-driven systems.
Servos were in commercial automation since the 70s, where a stepper just did not carry the accuracy and fundamentals required for machining at a higher full-scale application. Now, what we see with the new technology of micro-stepping drives, hybrid stepper motors, and we've got even closer tolerances with our machining principles, we can get steppers that perform as accurately as servos. And guess what, guys? That's not me saying that. That's Oriental Motor, one of the largest manufacturers of stepper and servo motors in the world. I'm also going to put in a document snapshot of everything you want to know about stepper motors, and this is direct from them. Okay, we've got the document right here, everything you need to know about stepper motors, the powerful ability of highly reliable stepper motors. Stepper motors are often misconceived as the lesser of servo motors, but as a matter of fact, they are highly reliable just like servo motors. The motor operates by accurately synchronizing with the pulse signal output from the controller to the driver, achieving highly accurate positioning and speed control. Stepper motors feature high torque and low vibration at low speeds, ideal for applications requiring quick positioning in short distance. And then it covers over here, stepper motors, servo motors must have better performance. This is a typical response when asked about stepper motors. Obviously, there is a major misconception about stepper motors. In fact, stepper motors have been used in various types of applications, such as advanced equipment and accessible automated instruments. The reasons why stepper motors have been continuously chosen are explained in this article. Now, guys, you're more than welcome to read this. I'll pan through this slowly. It is a large document. And you can see here, why do you use a stepper motor? Easy to use, 34%, and a lot of guys don't realize that typically servos used to mean a lot of tuning. Now we do see new technology coming forth with auto tuning and more of the hybrid type servos where they're just basically a stepper with an encoder on it, but typically the full-scale servos, they do require tuning and much more in-depth PLC type setups. So ease of use, 34%, inexpensive, 17%, which I think should be much higher than that because we know servos, you're going to need encoder cables on top of regular motor cables, and those, of course, should be double shielded in both formats, where a stepper motor just needs a motor cable that's double shielded. Simple operations, no need for tuning, as I just discussed, and then, of course, you can see it goes over here, and it's explaining basically everything, and I'm just going through this real slow. So any of you that would like to pause the video and read the entire document, please, by all means, do so and educate yourself the right way by documentation coming from a validated manufacturer. Once again, they actually sell both servos and steppers so that you know exactly what you're purchasing for your application. Nothing here should be smoke and mirrors and should be based on end user opinion. It should be based on fact, and then you guys then decide how you want to take your hard-earned money and spend it. I can tell you truthfully, I've done this well over a decade online. I can easily carry servos, but for 95% of my clients' applications, they will not see a difference. And if anyone's ever spoken to me, you can ask them yourselves. I'll tell them that I don't carry servos unless they are directly requested or I'm doing a consultation, mainly because of the complexity of older servos. And then on top of that, what you can achieve with stepper motors. And this is why we see predominantly stepper motors being used with 3D printers. As a matter of fact, I don't know many, if any, 3D printers that are using servos because honestly, there's not a tremendous benefit as there once was.
Once I find the information, I'll post how much this one costs for my system here. To do with feedback to that stepper drive, thus closing the loop. Now, what is the purpose of that? As mentioned, stepper drives start losing reliability as you push the envelope of performance.
Stepper motors or servo motors lose reliability if you exceed their operational envelope by increasing their performance. Think about what I just said. That's the truth. Fact of the matter is, it sounds like this gentleman went online to a forum. Some guy told him he bought servos. He asked him questions about them. Then he said, hey, you know what? I might change over to him because what you have sounds better than what I have. And now he's trying to convince everybody that, hey, what I bought makes sense because he's a YouTube content creator and he's trying to project that he's an authority on this subject. Unfortunately, he's been proven wrong time and time again. We're going to continue to do so by me showing you the accuracy achievable with a stepper base system, the G540, which is my system from a past client of mine.
Now, for me, performance wasn't a real critical issue here on this CNC. It's a hobbyist machine.
I love when these guys say it's a hobbyist machine as if they don't care about accuracy, and that realistically this guy didn't just go out and blow $600 on servos for a machine he's not planning on making money. But let's see, if we listen carefully, if he's actually telling us the truth, because I think he's fibbing, and I believe we're going to see it real soon.
I wanted reliability over everything. But I started getting into doing CNC carving. And I'll be having a number of videos up on the website here real soon covering this. But the problem with CNC carving, if your performance isn't high enough, meaning that your RPMs of your router and most importantly, the velocity that you can achieve with feed rates, if you can't get fast enough feed rates, your tool rubs too much, and on certain woods like cherry, you will get a lot of burning.
I always find these portions of the video really interesting, as many of you do, where an end user has this issue which he can't put his finger on. So he goes online, he researches at a forum, some guy says, hey, it's because your feed rate is too low, which is openly available on Google, and they immediately go to replace a piece of hardware and just claim that the hardware fixed the issue. And that could very well be the case. Unfortunately, many times, more so than not, because a CNC robot is a tool, just like any form of work, if we change the end user using the same tool, we'll get different results. I can have two clients run my same system and get two totally different results running the same file. Why? Because inherent variables of education of these two end users around the principles of use of that CNC robot. Now, thinking in lieu of what I just said, could it be possible that his end mill may have been dull and he may be doing extensive work with these type of relief cuts that could be causing the same result? Possibly. Because I can tell you from the size of his router, I highly doubt feed rate was his issue. He could have achieved a better result, a more economical result, just by saying, hey, you know what, I'm going to do a real trial and error diagnostic to see what I can do to correct this rather than drop $600. But the truth of the matter is, once again, that's not as cool as going on a forum, talking to some guy who says, I have something better than you, and you think that, and then you go out and drop the money so you can keep up with the Joneses.
A massive benefit and improvement in performance for that application as well. There's a lot of little tiny moves there, and it's very easy for a marginal system to lose steps, lose accuracy, resulting in a scrapped component.
Hey Vince, I hope this finds you well. Had a general situation over there. I just wanted to share my engraving work. Just made an awesome result for your reference. That's a 3mm character height and 0.1 millimeter engraved on a really crap piece of aluminum, 1 millimeter thick. So once again, I'm going to cover with you the videos that he sent. This is his machine performing calibration. The distance here is about 150 millimeters to 200 millimeters he's going through. You'll see this in another message. Now, I cannot emphasize enough When we cover the resolution, this is where things really get impressive. I know many of you are thinking this is, like a thousandth of an inch indicator. It is not. I'm going to let you watch some more of the videos. This way you can see exactly what he's working with. Here's from a different angle. You can hear how, you can hear how smooth his motors sound. I mean, the transmission on this machine is stock. He hasn't done anything. He's just doing fine-tuning and motor setup as far as motor tuning and dialing in the speed rates. You guys can see the repeatability on the indicator. It fluctuates very, very, very minimal. Okay. Once again, he fluctuated all the way from, we'll say, 2,000ths to 1,000ths. I'm not going to tell you the graduation yet. As we go through, I'm going to show you now actually engraving. Here we go. You can see he's got his mist cooler on, and he's engraving in aluminum. The tip on that is 0.1 millimeters, again, on the actual engraver. Okay, go to the next one. This one gives you really up close and personal look at exactly what he's doing. Once again, 0.1 millimeters, that tip is. You can see just how clean that goes right through. And again, with the mist cooling, he doesn't have it on real high, but you can definitely see it's doing its job. Definitively, this video really clarifies just how accurate these machines are when they're set properly. Once again, you hear the motors, how smooth they are. And we'll go back. And here is the finished template he made. You can see how clear that is. Now we're going to cover the resolution that that indicator reflected as far as accuracy, which I think is most impressive. I naturally asked him, the indicator is at Mitutoyo in the message. You guys can follow this through. I'm just going to skim across this. This is what his response was. Thanks for your prayers, Vince. So far everything is okay nearby, but we are really living a disaster movie-like situation. Unreal anyway. We'll win. Back to the machine. The indicator is 1,000th of a millimeter resolution, but a Chinese one bought off Amazon. For your information, the travel distance during measurement on x-axis was 150 and 200 millimeters on the y. Absolutely no problem if you want to post the videos, because of course I always ask everybody if I'm able to use their videos. I will go ahead with fine-tuning in the next days and test at different speeds for a longer time to get motors well warmed up. I'll try and send more video with a first cutting or engraving test, and that's exactly what he did. Again, you can see this is my account. There's no joke here. So let's go over resolution. When that indicator was reflecting 0.002 millimeter, that's the equivalent of 0.078 thousandths. So it's not even, it's well under 1,000th of an inch, guys.
Router. Now we'll take a look inside the control cabinet so that you can also see the stepper drives and how that's integrated with the stepper motor and the encoder.
Once again, guys, just like many of the other content creators I've shown videos on, this individual cannot wait to get you inside of his control box to go over how he wired his drives. And unfortunately, he's failed once again by putting the VFD literally beside his drives. Now, this explicitly goes against any user's manuals for VFD. They plainly state that you can have signal corruption if the units are mounted too close to signal wires. I don't understand this. I brought it up to many past clients of mine and potential clients, and typically the challenge I get is that end users will say, hey, you know what, I'm not having problems as of yet, it looks clean, and I'll never understand that thought, because basically what you're saying is unless there's a direct problem with signal reception, you basically wait for the machine to create a brick or a blem before you decide to correct something. So essentially you want to do work twice, and you would rather spend money in the long run twice. Guys, please be careful who you learn from. This is something that I've seen time and time again, as well as you now, because you're seeing them in my videos. I'm telling you, take your time, do it right, spend wisely, and listen to the right people.
Here are the three closed-loop stepper drives, X, Y, and Z. The way to implement this system. Let's say it's, for simple explanation right now, let's say it cost me $500. In the performance gains alone, I would say yes. I don't make money. Well, I do kind of make money with the YouTube videos, but
a lot of these guys like to claim that they're just hobbyists. And once again, he did expose the fact that he's making money with this machine on YouTube because he uses it to create content. And this is what many of you have seen. When I hear that guys are truly using their machine as hobbyists, first and foremost, they're not buying servo drives like you know. They're typically buying the cheapest machine they can get to do content with and just fool around with. Guys like this claim they're using it simply as a hobbyist, yet he was so extreme as a hobbyist, he felt he needed servo drives, and then he showed us his relief wood product, and we're to believe that he's just making one of those to show on his YouTube channel, and he'll never sell it. Well, guys, I don't buy it. Let's see what happens.
very, very fine point. So every bit of precision that I can put into the process, the better probability I'll have a good product coming out on the back end of that.
Well, it looks like our content creator accidentally slipped up again and exposed the fact that he's creating products, in which case he's not a hobbyist, he's an aspiring business owner. I hear that term hobbyist once again thrown around all the time, and now we get the truth. And me as a vendor, I can tell you it's despicable when I hear aspiring business owners use the term hobbyist in some way to make it seem as if they don't care if their machine has accuracy, or it's some low quality robot that they just are going to use temporarily accurately and hope for the best. No one wants to cut a circle and get a square, and no one wants to cut a square and get a circle or a mismeasurement. They expect accuracy at all dimensions, and they expect accuracy when using a production robot. Guys, it's despicable when people like this try to create YouTube channels and create an audience based around fictitious results of them trying to regurgitate what they see in forms and try to act as if they're an authority. That wraps up another video, guys, and once again, I hope that now you have the tools and resources to go and do your own due diligence, because again, I always tell you guys, don't take my word for it. Use Google, use all your resources, and become educated. And once you know exactly what you're getting involved with whatever motor you choose, at the end of the day, I tell my clients all it's the same thing. You're basically looking at who can cut a circle and who can cut a square accurately, and both of these motors will do that. The bottom line is which fits your budget and what are you trying to accomplish. If you're just getting started, believe you me, a stepper is all you require. And like I said, 98, 99% of you, that's probably all you're ever going to need. So be aware of what you're looking at and watch out for certain YouTube content. It can get you into trouble. Take care.